2.
All right, we're back, and we just solved a problem finding the equation of a straight line for a function which was an implicit function. Now I want you to, this is a you-do problem. The way you can do this is you can stop the video, do the problem, and then re-enter. I don't know what we-enter is. Re-enter the video, and I will do the problem for you. Or you can keep the video going, and I can continue with another problem, which I'm going to do anyway. Whether you stop it or not, I am going to continue with another problem, but I am, by the end of this video, do this problem for you. So you can stop right now, and I'm going to go on. Are we recording?
Oh, yeah.
Oh, I thought you stopped. Okay.
No, they can pause.
Okay.
We keep going.
Okay, so let's take some example problems here. But first, let us do some.
I mean, unless you want me to do the problem.
Well, okay, so let's do some log and exponential problems first, before we do some practical ones. Okay, so let's say we have given, I have the natural log of xy equals 6. Well, in order to do, notice there's xy in here. This is not separable. In order to do most implicit differentiation problems, we always want 0 on the right side. So I'm going to just make this like all the other problems. Now there are two ways to do this. So there are two methods. Method 1 and method 2. Amazing. How does he do it? Okay. The first method is to simplify the problem using a log rule. I don't know what that says, but it doesn't say problem. Okay. I don't know if you ever ate in Jersey, but it looks like tail of pork roll. All right, so let's use the first method first. The second method is not using the log rule, and in this case, we have to use the product rule. But we also have to do a substitution. Let's do this one first. Okay, so I want to simplify this by using a log rule. Now what I'm going to do, I'm going to put this problem on the bottom here, over there, so I don't have to go back and search my notes. This is the problem that I had you do. That's a minus, right?
Yeah.
Plus 10. Okay, so let's get rid of this. And let's use a log rule. Well, notice one of our log rules says that the log of xy can be log of x plus the log of y. So I can take this function here, and I can make it the log of x plus the natural log of y minus 6 equals 0. Notice this no longer becomes an implicit problem. I've taken the implicit differentiation right out of it by applying the log rule, and all I have to do, if I can catch my top there, is to take the integral of each separate step. All right, so I want to find dy dx. All right, I can take the integral of each separate step. d dx of the log of x plus d dx. Well, notice I still have to do implicit differentiation here. I'm sorry about but it becomes simpler. All right, so let's see what happens here. Let's erase this to get some more. So, what is the log rule? That is 6. That is a 0, sorry. It looks like a 6, but it ain't. It is a 0. So what's the log rule? Well, if we go back to the log rule, it says that the derivative of the natural log of x is what? Everybody remember? 1 over x? Correctamundo? Everybody with me?
Sounds good to me, Dr. Mirabile.
Okay, so the derivative of natural log, this is going to be 1 over x. Now here, it's a y. So I got to go d dy log of y dy dx. So there's the implicit. Minus 0 equals 0. So now, what do I have here? Well, it's 1 over x plus the derivative of the log of y is 1 over y dy dx equals 0. Let's erase the rest of this sucker. Bring the x one at this side. Dy dx equals minus 1 over x. Divide both sides by what? 1 over y. Crosses out. Dy dx equals minus 1 over x over 1 over y. Now, this is where everybody seems to have a bit of a problem. We have a fraction in the numerator and a fraction in the denominator. And they're variables. Very simple. Write the denominator as it is and flip
The numerator.
I'm sorry, write the numerator as is and flip the denominator. That's called the inverse. And you get here the answer minus y over x. Okay, and that is your dy dx. And once again, you did solve it implicitly, but I made it a little bit easier. So here you had to know the log formula, natural log formula, which all these formulas will be given to you on exams when you have it on an exam sheet. I don't know what I did with my blue top.
It's right there, behind you.
Oh, behind me. Oh, thank you. Okay. So, how much time?
We have 5 minutes.
Okay, so shall we try the next way? Let's try method number 2 and see which one you prefer. So let's keep the answer minus y over x. If we use method number 2 and it's correct, we should be able to get the same answer. Okay, so this is method number 2. Works better with the top off. Okay, method number 2, no log rule. I know some of you would avoid log rules at any cost. So let's see, we had y equals the natural log of xy, was that minus 6 or plus 6? Minus 6 equals 0. So you want to find dy dx. Well, what do? You got to use a u substitution here. I'm going to work on this. I'm going to say let u equal xy. When we have a u substitution, I have to find du dx. Now this is a product rule. X times the derivative of y with respect to x plus y times the derivative of x with respect to x. That's a product rule, correct? Everybody with me?
Yes, Dr. Mirabile.
Okay. A voice from nowhere. Now this is I cannot take the derivative of y with respect to x, since that is a y, so I have to use the chain rule here. What's the derivative of x with respect to x? Well, it's just a constant in front. So this is going to be y times 1. This is going to be x, set up our dummy, d dy times y. Sorry, that doesn't look too good. And our dummy variable dy dx. Minus, of course, the derivative with respect to x of 6. And that is 0. So here we get the derivative of y with respect to y is 1. So it's x. Doesn't look like a y. Sorry about that. X dy dx plus y equals 0. Let's bring the y over. X dy dx equals minus y. Bring the x over. Dy dx is minus y over x. And notice that's the same answer that we got before. Now it's up to you. If you like to use the chain rule, fine. If you don't like, don't worry about it. Okay, so that's actually a very easy way of doing this. Now, what did I miss here? What did I miss here? All right, this actually gave me the answer. I actually pulled a fast one on you, but I think I might just let it go. Okay? I did pull a fast one because I knew the answer beforehand. Let's let it go for now. We'll do another one like this. I just don't want to go back and confuse you because you can get the answer this way. I will do another one like that. So let's go back and we're going to do the problem you did. So I'm going to write the problem here. And let's write the problem over here. And it was the you do problem. Is it going to end?
Yeah, we only have 30 seconds or so.
All right, just go write down. Okay,